Hello, is my mic good? Oh, testing, testing, 1, 2, 3. Hmm. Bum bum bum. Bum 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 bum. Bum bum bum. Okay. Let's check the rain the next 2 weeks. Rain chances next 2 weeks. If you're in Oceanside, looking pretty good. Okay, wait. Next 2 weeks is what? The 6th of June. Me. 6th of June. And look at that. No rain. Unbelievable. It's literally summer. Of course there's no rain. Let's see. Is this obviously here's Los Angeles. Here. Rain, rain. Nope. No rain for the next 2 weeks. At least. Right now. Temperatures the next 2 weeks. Maximums. Looks like we're gonna be in, okay, this is the 30th. We're gonna be in the 80s. Let's see what this says. Remember, with forecasting, you have to compare different. Okay, this one didn't even go up to 80. This one goes up to 75. It does go up to 80 the 5th of June. And you also go up to 80 in the 5th of June. So it looks like the 5th of June is going to be in the 80s. That's considered hot. If you're in Mexico, for example, you're in yikes territory. Let me see if I could check Mexico. Yeah. In Mexico, anything over what? I don't know. 90 F. Anything over 32 is over 90, and here you see 35, 36, and for the next 2 weeks, boom. So down in Mexico, you're in a super heat wave. Anything over 3 days over 90 is considered a heat wave, and it's been like this for like a month and a half. Over 90 degrees in Mexico. I'm pretty sure that's considered a heat dome. If you're in Mexico, you're in Mexico, you're in yikes territory for the next 2 weeks, at least. So yeah, to be expected. Los Angeles weather boring, Mexico hot. Now let's check what we all came here for. Tornado time. So it looks like Saturday is going to be a tornado day. A very, very potentially very dangerous tornado day. Here's a 500 millibar chart. 500 millibar, which is like 5 miles up into the atmosphere. These are like rivers in the atmosphere. Here's like a pocket of strong winds here. Here's a pocket of strong winds here. The one we're focused on in this pocket right here. Let me erase the other ones. This pocket right here. This is for Saturday evening. You see you have 60 knot winds coming out of the west. If you go down to the surface, you have a 993 surface low in western Kansas, and that's bringing moisture from the Gulf of Mexico up to the central United States. Checking our dew points, which is your moisture, you see 75 dew points. That is very, very high. Very high dew points. So here I'm drawing the dry line, meaning the boundary between dry air and moist air. Here you have a 75 dew point, that's moist air. 18, anything over 60 is considered moist air, humid air. So, and then look, this is 65, so that's way over, that's 75, so that's way over 60. Here's 17, that's dry. So your division between dry and moist air is this line. So here's your dry line. Going up to 850, here's your low level jet. Your low level jet is anything over 30 is when you're looking for tornadoes coming out of the south. And here you have a low level jet of 40 coming out of the south Saturday evening. So you check your instability right here. Your instability, your mixed layer CAPE. CAPE is instability. Here, your CAPE is for representative. Blah, 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 blah. Okay, here's your instability, how unstable your atmosphere is. You want anything over 1,000, 4,900, and 45,000. Anything over 1,000 is good for tornadoes. And here you have 5,000 CAPE. Okay. So here's where your, wait, let me go back to my 850. Here's your low level jet, which I said 30 is important for tornadoes. Let's color in anything that's over 30, which is anything that's in color basically. Like that. So let's just go for Oklahoma City, 7 p.m. Saturday. Whoa, whoa, whoa. So this is a forecast sounding. This is showing you basically your environment. I'm explaining from top left to go down. So here's your the temperature of the atmosphere going from the surface all the way up to 15 kilometers up into the atmosphere. Your surface is 75 dew point, 85 temperature, and you see this whole, there's a like white line is the temperature of the clouds. Let's make it simple. So when your red line, when your white line is to the right, here, let me go back to coloring. When your white line, this white line is to the right of this red line, this whole area in between is your instability. And here, like I said, anything over 1,000 is good for tornadoes. And here, your instability is 4,000. Okay. Next thing you want to look at is your SIN. Anything over negative 30, so negative 35, negative 40, that's bad for tornadoes. So anything less than 30 is good. So negative 26, that's good for tornadoes. Your LCL, that's this here. That's the bottom of your cloud. You want it less than 1,500. Here's at 958. So it's less than 1,500. That's good. Your LFC, you want it less than 2,000. Here's at 1670. Okay. Your 3 CAPE, that's your instability in the lowest 3 kilometers in the atmosphere. So that's anything, that's your instability down here. You want this at least 50 for tornadoes. At least 50 for tornadoes. And here it's at 110. Your lapse rates, that's the temperature. That's the rate of decrease in temperature the higher you go up. Here it's saying surface to 3 kilometer lapse rate is 7.6 Celsius per kilometer, meaning for every kilometer you go up into for every kilometer you go up into the atmosphere, the temperature is dropping 7 centigrade. And you want this to be at least 6.5 or higher, and here's at 7.7. So your SRH, here's your wind shear, here's your wind shear numbers. That's good for these are very important for looking for what your tornado strength is going to be, kind of. So this top number you want at least 150, 230. This one you want at least 250, 330. At least 200, 260. You want this number to be at least 30. It's 60. You want this at the top to be like this shape, and that's what it is right now, like kind of like a reverse R. Like if R is like, I've never drawn an R in like 50 billion years. An R is like this, right? Okay, so if it looks like R, which it looks like right here, then yeah, and then this is good for tornadoes. And basically, so it's basically, here's what it's predicting. It's predicting a PDS tornado, meaning a particularly dangerous situation tornado. Like for example, down here it's saying the risk of a tornado of like, it's basically at night, like how do I explain this? Like it's like, okay, like for example here, like if this like purple line is like at a down here, that's like a risk of a category 3 tornado. If it's like right here, that means there's a category 4 tornado. Here for this day, it's showing going up to 9, meaning there's a very, if storms form here in this environment, which is not a guarantee, but if a storm formed in this environment, it has a very high chance of being a very, very, not very, very, but it has a chance of being a pretty strong tornado. So is there going to be tornadoes? Let's see what this is like a medium resolution. This is like if I put an example, this is like 10, like this is like 720p resolution. I'm just like, you don't have to know what that means. Wait, I didn't realize that wasn't even, for some reason I was, let me just do that one more time. Wow. So I wasn't even in the right, I wasn't even in the most recent, like model. I was like somewhere like in Thursday or something. Here's the most recent model as of a few hours ago. Here's the most recent predictions. And that sounding I just pulled here, it has 5,000 CAPE, 6,000 surface CAPE, has over 171. The other one had like the one I took like right after this, not the like the one I've been talking about this whole time, but like there's one that had like 203 CAPE, at least 50 you want. Here it has a 203 CAPE of 5 and almost 6,000 instability parameter. Here it was at 8, now it's at 11, and this is most recent, like this is most recent prediction. An 11 tornado parameter for Saturday after evening. It is 7 p.m. Saturday in Oklahoma, showing a very, very favorable environment for very strong tornadoes. I go back, if I now let's check the high resolution, like this is like a medium resolution models, but I was explaining, not even realizing that I was in the wrong one. Your high resolution models, this is like 4K essentially. This is like showing you exactly individual what could happen. So going to Saturday, this is actually showing that no storms form in this environment. If I check other ones, there's like almost no storm. This one has a storm forming at 10 p.m. Saturday. In a pretty favorable environment. 5,085. It's still having an 11. But if I compare all of these, let me go 48. If I compare all of these, HBR, most of these are showing that no storms are forming in Oklahoma at 7 p.m. That would be like if you're a storm chaser, you don't want to see that, but that would be very good for the people of Oklahoma that no storms form in this area. Like, how many that am I comparing? Like at least like one, two, three, four, five, six. I'm comparing 7 models, and at least like 5 of them show that no storms form at 7 p.m. Saturday evening. That would be a good thing for the people of Oklahoma if there would be no storms at that time, because the environment that these storms could happen, if storms did happen in this environment, they would be very, very strong, violent tornadoes. But at least 5 out of the 7 models I'm comparing right now, like show that there's no storms forming at 7 p.m. in Oklahoma. Now, obviously, take notice that this is 48 hours into the future, and anything could change. Very, like, not very, but there's a lot of times where these are wrong, even the day of, even 12 hours into the future. Right now, we're predicting 48 hours into the future. There's a lot of times where even 12 hours in the future, it's saying that no storms are forming at that day, and then in that day does have a storm, and but as of 48 hours into the past from today's Thursday night, um, right now for Saturday night, it's not showing models. High resolution models are not showing that any storms are forming in Oklahoma. Because the day 3 outlook has an enhanced risk for severe storms from the Storm Prediction Center. Um, all severe hazards are possible, including a couple strong tornadoes. But that's if storms form at all, which high resolution models are not showing. There's one that is, which one I bet you it's the RRFS or the MPAS. One of those two. I bet you one of those is showing that. How do I get out of here? One of these is showing that there's storms. Not this one. These, who is showing it? You. I guess it doesn't go that far. Maybe you were showing at 18. No, like a bunch. Most of these aren't showing that storms are forming in Texas and Oklahoma at 7 p.m. Saturday, which would be a good thing if they don't, given the environment that is present. If storms do form Saturday evening, there there's a very high chance that they're going to be very, very dangerous. Okay, well, that's tornadoes, and that's for that day. There's another day. Mm, Sunday also looks interesting. Sunday. Sunday. Bum 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 bum. Sunday at 4 p.m. So here's your wins. Is 69. Ha ha ha. 69 hours into the future. Let's check. I always start with dew points. Here's your over anything over 60. So anything in blue is good. 60. Lots of people start from the top down, but I just start from the bottom up. So there's a whole big area that's 60. 850 winds is this. Just do black. Something like this. Your 850. Well, that's basically that whole area right there. Your I do surface cape when the longer you go out, and you have a lot of three. What's the let me do this in another website just because it's easier in here because it colors in the convective inhibition. So here's 21Z. Here's 4 p.m. Sunday. Let me do all that. Can do points. Anything. Hit 50. Anything in yellow. Okay. So here basically. $500. Good. Your service based. Okay, this looks better. Like I should just ignore this top part because here it's going into 600 cape. So let me just cut off this part here. Okay. So this whole area. Wait, let me like here's a 500 vorticity is basically the area where it's promoting rising air, which promotes storms, and the highest vorticity is up here in Illinois. Let me just take a sounding here, see what it tells me. Even though it has maybe the warm front. Is this a warm front up here? Maybe. That's how. Well, here's the sounding. Here you have 4,000 cape, no inhibition, low LCOs and LFC, 119, high lapse rates. This is low. The top number is low, which will usually indicate that it's more of a hell environment. And here, if it's saying that this is like a thing that compares like a bunch of historical soundings. And here in the severe hell category has a bunch of like 3+ inch hell and greater. Like here's a 4-inch hell. Here's 3. So let me see one that has. Let me see one that has that has a more higher significant parameter. Like here in Eastern Illinois. Let me just do one up here and. Oh, this one I just took. Oh, okay. Here it's showing another PDS tornado warning. And you can see why. Here's 70 dew points going pretty high into the atmosphere. 82, at least 50, at least 6, at least 1K. Here's 3K, at least 150, that's 300, at least 250, that's 500, at least 200, that's 470. And here it is at almost at 10. So yeah, this is why Sunday is also a pretty significant day. We zoom into Illinois. It shows storms more like in a line, but here are more like if this one could be which one? Oh wait, what hour is this? This is hour 69. I think that's too far away to. So yeah. If this one's discrete, meaning it's isolated, tornadoes like storms that are isolated. So if this line that's like, it could be lined up here, but this one could be more semi-discrete. So like this like storm in eastern Illinois, not far from Chicago. Chicago's up here, but what does SPC have for this day? I haven't even checked. I have like a billion tabs open. Yeah, it's putting this day 4. So yeah, that's why it is up higher up here in the Midwest. I think earlier it had it more like this, unless I'm confusing it with a different day. But yeah, you can see why it's up here in Illinois because of this parameters. Maybe by tomorrow morning, we'll have some high resolution models to check out. So that's all for tornadoes. I know there's probably another day on Monday, but I'll just wait for the NAM to load for that day. I know I could use GFS, but whatever. I'll just one day at a time. This one doesn't have there's no day 5, so maybe there isn't a good significant day. Day 6, day 7, day 8. Now let's just check hurricane season, since hurricane season is about to start. Even though Tropical Tidbit said probably not till mid-June, which is common. I'll just check this, and I just like to go 2 weeks out. So June 6th. There's a little funny thing up here, but there might be, yeah. So this is June 5th. There might be some funny business down here. This is GFS though. If you, and yeah, wait, this doesn't. Yeah, GFS showed it, but the European model doesn't, and the European model is usually better for hurricanes than the GFS is. So far, at least the next 2 weeks, it looks like a quiet. I mean, hurricane season doesn't start till June 1st, and this is June 2nd. So, I mean, last year I'm pretty sure there was a June 1st storm already, but probably good tidbits in this video said that probably not till mid-June. But yeah, that's all for today. The 2 important things were that the day 3 that there's a high parameter for tornadoes in Oklahoma, but that's if storms, which currently most of the high resolution models are not showing storms. Oklahoma, at least at 7 p.m. And the other big day is going to be Sunday up here, which could have like a lot of time, like most recently, you know, that like this year Iowa has the biggest tornado count so far of any state. So if there's like storms here, like that's just intuition that Sunday could be a bigger day than Saturday if Saturday doesn't have any storms, then Sunday at least probably will. And Sunday is a holiday, I'm pretty sure. So yeah, that's all for today.